The top of the page has to do with vocabulary. So a square is not referring to geometry, but it's referring to a perfect square. Okay? So a number that when you square root gives you a whole number. Okay? So, is 16 a square? Yes. Is 25 a square? Is 48? No. All right? Okay, the next one. Ask for the quadratic term. And I know somebody had it right on their paper. What did they have? What did you have on your paper for quadratic term? It's the one with the x squared. And my linear is just the x, and the constant has no variable. So that you understand the different pieces of the quadratic. Is everyone good with that? Okay, I'll give you a second to copy that down before I move on. So, I then had pictures of different algebra tiles, because this is how you should have learned it when you were in Algebra 1. They should have given you some visuals. What does the big square represent? No, that was elementary school. Algebra, what does the big square represent? It represents x. So the big square is x squared. What is the rectangle? The rectangle is x, and the constant is the baby square. Okay? So you should have x squared, x, and constant. X squared, x, constant. Everyone following along? Okay. So in algebra, your teacher would have given you, if they wanted to show you the problem, x squared plus 4x plus blank, it looks like this, yes? Okay. And I need to fill it in so that you guys got to drag the tiles around. I need to fill it in so it makes a big square. So how many constants do I need? 4. Okay? Your teacher might have, to save time, would have done this, and then they would have gone 1, 2, 3, 1, 2. Oh, I did it the wrong direction. Hold on. Your teacher didn't do it this way to give you a visual? Oh, yeah, when you were in Algebra 1. Oh, 1, 2, 3, 1, 2, 3. Where they meet up, you put a dot. So if I have x squared plus 6x, the last piece would be 9. Okay, are we good? No. What is your question? What do you mean you need everything? Okay. So I'll show you another method in a minute for completing the square. So you did not do visuals when you were Algebra 1 to understand how, okay. So that is an issue because that's kind of a fundamental so you can visually see why it works. You guys didn't do the quilt problems? None of that? Okay. All right. That explains some of the shaky ground. Okay. All right, here we go. So we have x squared plus 2x plus blank. Everyone see that? Okay. I'm going to do this one with algebra tiles just so you can get a sense. All right? So I need one big square. How many rectangles do I need? 2. So one rectangle, one rectangle. To complete the image, how many singletons do I need? 1. I need one constant. So this would be plus 1. Okay? I'm going to do the next one. Same thing. I'm going to draw the picture for you, okay? So it says x squared plus 4x plus blank. So a square, 1, 2, oh, I did it backwards. Okay. 1, 2, 3, 4. That's the x squared. That's the 4 x's, yes? And I need 1, 2, 3, 4 to make it happen. Okay, so what goes here? 4. Great. Let me do another one. So then we have x squared plus 6x plus blank. So I have a square. 1, 2, 3, 4, 5, 6. Some teachers would have the kids extend the lines and they would count up the intersections. That's another way to do it. But how many intersections do I end up with? 9. Okay? Who wants to take a guess for x squared plus 8x? What's going to come after that? Yes. 16. Does anyone notice a pattern? So we have x squared plus 8x plus 16. And we kind of worked with this pattern in the last process.
For example, like the last
Uh-huh.
one. You divide the 8 by 2.
Okay, you divide the 8 by 2. So we divide the middle term by 2, also known as our b term, by 2. When else do we divide it by 2? When we were looking for the vertex, yes? Okay, and then you square it, which means to multiply it times itself. Okay? All right, so then let's complete the ones on the bottom. So what's half of 20 times 10? 100. Great. What's half of negative 14? What's negative 7 times negative 7? 49. And the last one's kind of mean. What's half of 5? 2.5. And 2.5 times 2.5 is 6.25. Okay? All right, ignore the back for a second. I'm going to pause this. I'm going to hand out some notes. Okay, so your paper has the steps for completing the square. So the first thing we have, and you can do it, I left you a little paper. We have x squared plus 6x minus 7 equals 0. It says move the constant to the other side. Which one's my constant? Negative 7. How do I move it? So I'm going to add 7 to both sides. Now I have x squared plus 6x blank equals 7. Okay? Then it asks you to divide the middle term by 2. So when we divide this by 2, what do we get? We get 3. Okay? So we get 3. Now they want you to square it. So what's 3 squared? 9. And I need to add it to both sides. Let me know if I'm going too fast. So we took half of b and we squared it. So half of 6 is 3. 3 times 3 is 9. Then I added it to both sides. So now I have the equation x squared plus 6x plus 9 equals 16. Okay? What number did I use to make that 9? What number did I use to make that 9? 3. So this becomes, once I factor it out, x plus 3 squared, because this is a perfect square, equals 16. What does the next step tell me to do? Square root both sides. Okay, let me get a different color. What happens when I square root a squared? They're inverse operations, so it goes away. So I'm going this way, sorry, I'm going out of order. X plus 3 equals what? Now be careful. Did I put the square root in or was it already there? So you have to do what? Positive or negative 4. Okay? Cool? All right, now we're almost done. So now we have the equation x plus 3 equals 4 or x plus 3 equals negative 4. How do I get x by itself? Subtract 3, so x equals 1. Over here, subtract 3, x equals negative 7. Okay, so you have a nice little note sheet. I should have put it on colorful paper so you don't lose it. Please go to the back of the warm-up, which is going to contain some of our homework. We're going to walk through one more example together, and then I'm going to assign a couple of them for homework. Okay? And then we'll call it quits for the day. All right. I'm going to look at number 1, which says p squared plus 14p minus 38 equals 0. Who do I need to move? 38. And it's negative, so I'm going to make it positive 38. P squared plus 14p equals 38. Now, how do I complete the square? Divide it by 2, that gives me 7. I square it, it gives me 49. What I add to this side, I must add to the other side. Now let's go ahead, since this is already here, let's go ahead and factor this. It's going to be x, what? Plus 7 squared. That was my magic number. Equals 7, carry the 1, 87. Okay? Square root it. Square root it. Is 87 a perfect square? No. So what we're going to do is x plus 7 equals plus or minus the square root of 87. So my answers are square root of 87 minus 7 and the square root of 87 plus 7, and you can leave it like that if it is not a perfect square. Are we cool with that? Yes.
If the plus and minus is in front of the 80 or the square root of 87, doesn't that change the value of 87? Not the...
Oh, sorry. I put it in the wrong spot. This is supposed to be minus 7, and this is supposed to be negative. Sorry. You are absolutely correct. I was going too fast. Sorry. I put the sign in front of the wrong number. Sorry, guys. Cool? All right. So it should have been positive 87, square root of 87 minus 7, and negative square root of 87 minus 7. I put the sign, I switched the sign in the wrong spot. I was going too fast. You should have both those answers. Okay? Now, your classwork / homework is the rest of the odds. What is an odd number? 3, 5, 7, 9. Cool? All right. I will post